Hey guys, welcome back. We're going to spend a few minutes talking about crankshafts, specifically in diesel engines. So your crankshaft here, we're going to go through and look at a few of the main parts first. You got your crankshaft. We've got your main bearing journals, which are the center line down this crankshaft. They're all perfectly in line with each other, machined to a very specific tolerance, down one straight line. That's going to ride in the main bore of your block. Off to the side here, we have the rod journals, also known as crank pins. These are all offset and are going to help determine the throw of the engine, which translates into the stroke. The offset, the dimension that this pin is out of that center line, in addition to the connecting rod, is going to determine the throw, which is part of your displacement formula for your engine. So when we're talking about a crankshaft, what does it do? Well, it's translating or converting linear motion from your piston here that's going straight up and down into rotational movement. And it's going to do that through the connecting rod being joined around this crank pin or this rod journal here, and spinning this shaft in a circular motion as this rod continues up and down. Diesel crankshafts must be extremely strong, and one key factor to that is this fillet radius. At each journal here, there's a fillet radius to where it actually rounds out a little bit. That is different than a lot of gas engine cranks, which are going to be much more of a straight machine and then goes into your cheek there. That's part of the reason that you cannot resurface a diesel crankshaft. You cannot turn these down. The manufacturers highly suggest against it because it's really hard to get that fillet radius back in there. Without that, these things are prone to cracking. That's also part of the reason why yesterday when we were talking about our rods, I was saying that if you have a V configuration of an engine, you're going to have a perfectly flat, no chamfer between companion cylinders, and this chamfered edge where it goes to the outside here. So this chamfered edge would meet that, and this crankshaft is actually out of a V design engine. That is why these rod journals are twice the size of the main journals, because two rods will ride side by side. One will be going off to the left bank, and one will be going off to the right bank as this thing spins around. This crankshaft has failed because you can see this damage to the journal here. I'll try and zoom in for you. There's damage to this journal because the bearing failed and started spinning. These journals are all lubricated from the main bearings. These oil passageways right here are fed directly from the lube pump in the block. They come to the mains, which are usually cross-drilled straight through. Can't quite see, you can kind of see the table through there. There you go. So those are a straight through drilling to try and provide as much oil as possible to the main bearings. These rod journals are then cross-drilled diagonally into that main journal. So if you kind of stick a screwdriver down there a little bit, you can see the angle that that thing's drilled at. Each main will supply oil to one rod, or in a V configuration, two rods. This main here supplies to this rod and this rod. This main here supplies to this rod and this rod. So there's always oil running through that crankshaft. That oil ultimately is lubricating your bearings. These are rod bearings. Rod bearings are similar to crank bearings. The size is determined by the engine. So this rod bearing out of a DD15 is actually larger than the main bearing from this engine. Way smaller than the main bearing from our 3516 though. Main bearings will often have a groove in the top bearing shell in the main. So this bearing would be installed this way if the engine were sitting in a vehicle, because that would be the top bearing. So your oil is coming in from your block drilling through that hole. It's allowed to seep either way to maintain a consistent oil film through that main. And then the lower bearing shell will have no hole, because you're not trying to supply any oil anywhere through that cap. From there, you'll transfer oil up and through to your rods. So you've got main bearings and rod bearings. Like I say, the main bearing will always have a hole in it. The rod bearing may or may not have a hole. The rod bearing having a hole is going to determine whether there's any oiling through that rod going up to your wrist pin here. So if there was a hole up here, that means this rod would be drilled for oiling to your wrist pin. There's many different designs of rod bearings. The original was made out of a lead tin Babbitt mix and is still used in some rod bearings today. The Series 60 uses sputter bearings, which the lower is hardened, and they can be good for 1.5 million miles. Series 60 is a Detroit engine. DD15 is also a Detroit engine. These bearings are also different upper to lower. The lower bearing is hardened, the upper is not. Why would the lower bearing be hardened? Well, there's a lot more force on that lower bearing. The weight of the crank is hanging on that lower bearing. So the four main important characteristics of your bearings here are compatibility. So you want dissimilar metals so that you don't have any kind of corrosion or gouging. Fatigue strength, so as you're carrying that load, you're not going to crack or wipe if there's too much force. Wipe would be a spin or a removal of material, similar to what's happened to this one. Conformability, you want those bearings to be able to conform to the precise size and dimensions you need. And embeddability, the ability to absorb dirt and to not scratch the crank. So these bearings can be sacrificial. You would rather this bearing absorb some dirt or contamination and not ruin the crank like this thing. Otherwise, you're pulling that whole engine and you're replacing the crank. These bearings will also have locator tabs often to make sure that they get installed the right way. And you can see if the bearings are different, remember, lower, upper, oftentimes those tabs will be set in a way so that you cannot install these bearings in the wrong location. Again, I say often, so you must always pay very close attention. When installing these, you want to wipe both sides and remove any oils. You want no oil on the back side of this, otherwise that can also promote spinning. Spinning is bad, mainly because these tabs will deform and then the bearing loses its concentricity. Also, because then your oil holes do not line up anymore. There will be metal transfer, you'll have noise, high or low oil pressure depending, and you'll need some major repair. So always install these dry on the backside Use manufacturer specified lubrication on the friction surface.